Welcome to Geology Talk, our monthly gathering of geology enthusiasts. My name is Paul Edison-Lam. Our presenter today is Nancy Schrader, who's pictured there with a mirrored bear up in Banff, Canada. She's going to be telling us about a recent Association of Women Geologists field trip to the fantastic and beautiful and amazing geology of Southeast British Columbia and the hot springs which arise because of that geology. So over to you, Nancy.
Okay. Well, thank you, Paul. Hello and welcome, everyone. From this picture, you will see, and you will soon see on the whole trip, water was everywhere on this trip. So here in my home in Western Montana, we often open public events with an acknowledgement like this. So I will do so here to honor the lands to the north. My land acknowledgement recognizes and respects the Siniyak and Kootenay peoples as traditional stewards of this land and the enduring relationship that exists between Indigenous peoples and their traditional territories. Mindy was our on-the-ground geologist tour leader, and Marcia handled months-long logistics. And I give a big thank you to both of them. So I do want to speak a moment about AWG. The Association for Women Geoscientists is an international organization devoted to enhancing the quality and level of participation of women in geosciences and to introduce girls and young women to geoscience careers. Membership is open to anyone who supports AWG's goals. So our route, sloppy on Google Maps, but I did it. 20 of us met in Revelstoke, British Columbia, from across the US and Canada. There were 7 cars, about 1,100 miles, 11 days, 9 accommodation changes, 10 hot springs or pools, about 4 geo stops per day, and 1 gondola ride. And as you can tell, there were many moving parts, which included routine travel issues such as weather, road closures, and vehicle hiccups. We did a counterclockwise tour, first heading south in the West Kootenay region to return via the East Kootenay region. In this lecture, I will tell you about the field trip, the foundational geology, more recent mining and glacial activities, and I will show you pretty pictures of water, hot and cold, moving and still, and rocks, lots of them. We learned about the Omaneka and foreland belts of the original western edge of the North American continent before accretion of the exotic terrains that now form much of western British Columbia and Washington state. This land mass has been part of many ancient rifting events and continental configurations, mainly Laurentia. This area is also important for researchers in the US because most of this same geology is now covered by Columbia River basalts. I just needed to add this to my presentation for your future reference. And I also want to note that these sedimentary rock layers in many cases have been metamorphosed to what I may refer to as metasedimentary rocks. So here's our view from our first group meeting in Revelstoke. From our restaurant balcony, we saw Mount Bigby, a volcanic plug in the Monashee Mountains. In this area, the older basement rock of the Laurentian supercontinent, which existed long before the breakup of Pangaea, has been exhumed by extensional faulting in more recent times, wreaking geological havoc, which I'm not going to go into. Later the next day, we were able to walk on a contact between metasedimentary rocks of the Lardot group and younger plutons and batholiths. This was on the east side of the Arrow Lakes Reservoir at the ferry landing. On day 1, we are first made aware of the effects of the Columbia River Treaty signed in 1961 between the US and Canada. The treaty required Canada to provide 15.5 million acre-feet of water storage and provide flood control by building 3 hydroelectric dams. This area was flooded by the High Arrow Dam, now known as the Keenleyside Dam. The 2 flooded lakes, which were originally 14 miles apart, are now one body of water. The entire project flooded 2/3 of the arable bottomland and displaced 2,000 people and 13 communities. Obviously, this is at low pool. The town of Beaton was originally the ferry landing on the east side of Up Arrow Lake. It served as a settlement for mining communities and was part of the steamboat network on the Columbia River in the US and Canada. Dam construction raised the water level by 40 feet, so only scattered residences survive today. Of course, we didn't identify the thousands of beautiful rocks we saw and picked up. There is a coral fossil near the center of the left-hand photo. We attempted to visit Camborne, a mining ghost town. The road is impassable now and will likely remain so. We looked at some highly deformed phyllite and enjoyed a noisy tumbling river. We saw box canyons, narrow chasms, and waterfalls throughout our trip. We spent a long day driving in the drizzle north of Caslow. Here's our lunch spot at the Twin Bays Recreation Site. Some parks were still seasonally closed, so we had to improvise at other locations. The cartoon on the left explains the simplified process of creating surface hot springs. The water source is snow and rainwater in the mountains. As the water descends in fractures to circulate deep in the earth, it is heated and highly pressurized. If there are steep and permeable faults underlying a nearby valley, the water will reemerge as a hot spring. Similarly, when there was active faulting 50 million years ago, hot rock was lifted to shallow depths. Mineral-rich hot waters then led to the formation of many veins of ore. Now for a commercial break. Halison Hot Springs was our 2-night stay at a condominium resort. Halfway Hot Springs was up a drive up a 7-mile gravel road and a steep walk down 150 steps to a series of pools next to the creek. There is an ice changing shed and camping is allowed. What a contrast between the two. St. Leon Hot Springs was reached by a 7-mile round trip hike on a closed road and woodland trail. A small group of us made that hike while the others made time for an after dinner 9-mile drive to Nakusp Hot Springs from our motel overnight in the town of Nakusp. Both of these facilities, Ainsworth and Fairmont, had natural travertine deposits on the premises. Travertine is a terrestrial limestone formed by precipitation of the calcium carbonate from emerging spring waters. Studies show that the radiation dosage is minimal for a half-hour bathing at Radium Hot Springs. The hot pool that receives water directly from the springs is 111 degrees Fahrenheit. Lucier Hot Springs is beside the road up to White Swan Lake. There we saw only our second fossil, an Archaeocyatha, and that's a short-lived Lower Cambrian sponge. Banff Upper Springs was on the hillside above the town of Banff. The indoor pool was at our fancy hotel, which happens to be a UNESCO World Heritage Site. Our mining experience began in Silverton and nearby New Denver. We are here on an alluvial fan that was formed by many cobbles coming down from the higher elevation mining areas. In other locations, we saw examples of more recent mass wasting events. One of our stops was in the ghost town of Sandon in the Selkirk Mountains. This town was founded in 1892. The mineral of interest was galena, a sulfide mineral that with processing produces lead and silver. As we traveled over to the East Kootenay region, we stopped at this road cut. The Windermere Group represents about 600 million years of geology, starting with the calcium and magnesium carbonate called dolomite on the left. In the center is the Monk conglomerate with blocks of that same dolomite in a greenish matrix. And at the younger end and to the right, east, are green fragmental Irene volcanic rocks. Downslope several miles to the east is a major unconformity atop the erosional surface of the Purcell Belt supergroup. That unconformity represents about 500 million years. And to remind you, in the US, we are more familiar with the belt rocks name. They are the same thing. Here is a close-up of the Monk conglomerate, the center feature of the previous road cut. Previous homogeneous dolomite has been broken up and relithified into a conglomerate. And this is the Toby conglomerate, which is the base member of the aforementioned Windermere group. Most conglomerates present a story or mystery about the preceding geology. The imbrication shows the power of water. You can see the layering of the rocks showing the direction right to left of the water flow. It was very obvious from the creek side. And this was one of my favorite stops. It's hard to see, but one of our jokesters scratched in pencil cleavage on the cleavage face. In addition to typical glacier features found in the upcoming Banff area in Alberta, we are aware that the route of the Columbia River was changed by blocking from the ice sheet. The most unusual feature being that the river's direction changed to flow north for 200 miles before going south again, as noted by the wiggly purple line in the right-hand map. Our driving route was basically on the text that reads the future site in Nelson. Please note that the dotted border line between Alberta and British Columbia is also the Continental Divide. That line of light-colored hoodoos was formed in the glacial outwash stream deposits of the last glacial maximum 18 million years ago. This valley's geography is strongly dictated by the Rocky Mountain Trench strike-slip faults and later by multiple glacial ice advances and retreats. The physiography of British Columbia is highly influenced by all types of regional faulting. You name it, and it's here. Hoodoos are created by subaerial erosion of exposed rocks. The process can occur on all sorts of soft rock types. This catch-all term originated in North America, but the features can be found worldwide. We have now traveled into winter. One hike to the paint pots was eliminated because of the conditions, but some intrepid folks made this round trip 2.5 mile Marble Canyon hike in the snow. A video like this shows you again the power of water. The Marble Canyon Formation is a thick limestone and dolomite layer formed in tropical waters. In fact, the name is a misnomer because the bedrock here is a microcrystalline limestone, a sedimentary rock, rather than a marble, its metamorphic rock cousin. Because of the formation's matches around the Pacific Rim, we know that broken sections of the original limestone shelf traveled incredible distances due to the plate movements of continental drift in Permian time. Marble Canyon is also popular with climbers, both for its clean rock walls and for its ice climbs, including one on a waterfall that freezes solid in the winter. And this is coming into Banff. Mount Rundle has a classic dip slope surface, in this case formed on the Rundle Group dolomite. So I'm more of a mountain girl, so I passed on some of the hot springs. Here, a fellow traveler and I took a gondola trip instead. We didn't have those clear blue skies that day. From the top building complex, I took a 1 kilometer round trip hike and boardwalks to the top of Sulphur Mountain. Sulphur Mountain Formation was deposited on the continental shelf along the western margin of the North American craton. A craton is a large stable block of the Earth's crust forming the nucleus of a continent. This was Lake Louise, over a mile above sea level. It was 41 degrees Fahrenheit that afternoon and wasn't quite the view that is seen in most photographs. This is a glacial cirque lake in the hanging wall of the Simpson Pass thrust fault. The rocks are mostly Cambrian quartzite. So this was our last significant stop. As we walked along this complicated and very interesting road cut of the Mayan Slate, we were curious about so many features. What's the bedding? What's the cleavage? Are those ripple marks, et cetera, et cetera, et cetera. Every 10 feet, we had a different answer. When I found this photo online at home, I didn't feel so baffled. This and the previous slide made up a metaphor for our entire trip. We were blindly touching all parts of the elephant, not fully understanding the complicated story of British Columbia geology. Here are some useful guides to travel with: the tried and true roadside geology book of Southern British Columbia, and 2 multi-page guides that can be printed from the internet. So take it away, Paul.
Thank you, Nancy. Excellent presentation. We have a lot of questions from the chat here. The springs are radioactive. Where does the radiation come from?
It's just part of its natural bringing up these radon's also often associated with granitic rocks. You've got hydrothermal alteration affecting this whole area. I can't tell you specifically what the radon's coming from, but I would just assume that it's the waters are passing through some of these granitic or uranium-rich rocks on the way up.
I see. I wondered if it was, we have granites here in Portland that cause radon in basements because we have Missoula flood gravels that contain a high proportion of granite. But I was wondering if it was something, beyond that, or just the, actually uranium rich. Okay. Other questions? When did the Cordilleran glaciation take place?
Well, my one slide said the last maximum was 18 million years ago, but other people can help me out there.
Well, it does look like Lindsay chimed in with that the Cordilleran ice sheet was covered North America during the last 2.6 million years. Other questions?
Yeah, I'm always trying to bolster my geology vocabulary. So I was curious about the definition of a fluvial fan.
Alluvial fan, the body of sediment, fan-shaped, generally formed where fast-flowing stream carrying a heavy load of sediment enters a broad valley and slows down and deposits much of its load. Now, not unique, but these were large cobbles. I mean, you can also call those fan-shaped deposits in the depth fans, and those aren't river cobbles, but here they were indeed river cobbles. So that water must have been going mighty fast.